In this lecture, I'm going to be covering motion programs, which also follows along with your chapter 11 in the book. I'll follow this with a demonstration using RoboGuide that you can use to help with the various labs. So we'll be creating a motion program. We're talking about creating a motion program through the Teach Pennant, how those programs can be named, the meaning of the header information, recording positions, and how to effectively test the program. So let's start by defining what is a motion program. So it's a set of commands that really tells the robot where it is, where to go, how to get there, which path it will follow, and how fast it'll do, and what to do once it gets there. So in motion programming, handling tool is the software that we are using. That's an application-based software used to create the motion programs. So on the Teach Pennant, just to break down what is available, the information that is available when displaying a motion program. So at the top here, you can see where we have the status indicators that we've talked about at the beginning of the class, and then we also have here an indication window that tells us which program is currently active, the line on that program in which we are, the status or the execution status, whether it would be running, paused, or aborted, and then also the coordinate system that the robot is in for navigation. So this is when we want to manually move the robot. So this can be different than what it is using to operate or execute the program. We also have here our speed override. So this gives us the percentage of speed that the robot will operate, and this will override any command that is listed here in the program. Okay. And then we, like I mentioned, we have the lines of code here. The symbol, this would be showing the end of the program. Okay, any prompting message we'll often get down here at the bottom of the screen. And then this will also let us know where our cursor currently is out of how many lines of code. We've got our how to create a motion program. So if we go back here to our select button on our Teach Pennant, so this would be one of the hard keys, it'll bring up a window that shows all of our programs on the for that robot, whether it be a Teach Pennant program or a different type of program. So the program that we would be creating by default when we select this Create soft key here would be a Teach Pennant program or a TP program. Just something to keep in mind, the extension that it creates, so that later on as we're trying to identify the program or save the program, which one would be the motion type program. So in this screen we can create the program name by selecting the different icons here or characters here that would describe that program based on what we decide. A couple things to keep in mind is that it would need to have the first character as a letter. The remaining characters can be a number, but we can't use any special characters or spaces. It'll default to creating all of the characters as uppercase. So even if you enter in a lowercase later on, it'll change it to an uppercase. If we utilize the words option here as our character input, it'll give us 4 different options that we can then select from, or a combination of. So program, main, sub, and test are often the common ones. Those can be changed, but usually that is what would be available. Then we can also make use of the uppercase, lowercase, or under options we can bring up a keyboard that allows us to type the information in through a QWERTY type keyboard that would pop up here on the screen, or here on RoboGuide it just comes with a little window that allows you to use your physical keyboard to type in the information. Once we've created the program name, we come down here to Detail, or you can select Detail, or you could just press Enter if you're good with all the default information on that program. But under Detail, it brings up some information that gives us an idea of what the program is intended for. So this first one is the subtype. If we select none, then it defaults to just any type of motion program. However, we can also select it as a macro, which can contain any type of motion instruction or non-motion instruction. The advantage of a macro is it can also be accessed or executed from a teach-pendant key or a special key or operator panel key. We can also create a condition monitor. These are a special type of program that will only execute as it sees a condition of a certain condition exist, either through an IO signal, a register value, alarm status, in which it would execute a series of functions. So it cannot have any motion enabled as part of that condition monitor. So this would just be something that would toggle states of IO or of memory registers. But we can use this as a way to monitor programs. And so it would monitor the conditions in a teach-pendant program, or a system monitor in which it's looking at different IO signals from either a PLC or some other external source. Down here we can, in the next item here in our detail screen, a group mask is a way that we can isolate this program to just specific types of groups of motion. So what we mean by that is the robot, it has 6 axes, and all of those 6 axes can work in concert with each other. So that is considered by default our group 1 motion. However, if we have additional axes, say like here they have a gripper system that is servo actuated, so it has a motor on here that opens and closes that gripper, and that can be identified as a separate group or motion group. And so if we had a program where we wanted to just have one particular motion group move, we would use this group mask to select one or unselect another, and then that would isolate the motion to just that group. We can also remove all groups or mask all groups here in this statement, even the robot. And so if we have a program that we want to make sure doesn't have any motion execution in as part of that program, then all of these would be stars. And so then that particular program would just be used for status, I/O monitoring, toggling, moving registers around, and so forth. All right, the remaining items on our detail screen, I'm not going to talk about. I think the book gives a pretty good description of what those items are: the write, protect, ignore, pause, and stack size. I'll leave that up to you to review. So once the program has been created, we can now enter in our motion statements. We do this by moving the robot to the target position, or the desired target position, and then hitting Shift and point, and that will create a position with the default motion statements. So, and I'm going to explain what that means. So our motion instruction is made up of several different components. The first component is our motion type. So this is indicated by either a J, an L, or a C, meaning joint, linear, or circular motion type. The next component is our position ID. So this is indicated by a P followed by a numeric value giving it an ID. So this would contain all the coordinate information or positional information of where this point was taught particular user frame or a specific user frame and tool frame. So this is where our robot is going to go. The next component is our speed. So this indicates how fast the robot is going to travel to that location. And then our next component is our termination type. Whether it's going to stop at that location or it's just going to do a flyby of coming near that location but then moving on. So just to summarize the different components of a motion instruction, or we have our motion type, our position ID, the speed, and the termination type. So those four components generally make up a particular motion statement. So I'm going to show in our demonstration how we create a program and then just create a simple set of motion instructions, very similar to what you'll be doing in your lab. And then we're going to test out those motion instructions using the step and continuous mode, and then we're going to do some modifications to those points. And so I'll show you how to do each of those. So I'm going to do a demonstration on RoboGuide of how to create a program, how to teach some points, and step through those points, and also run those continuously, and then how to make some modifications to those top points. So let's go ahead and bring up our teach pendant here, and I'm going to press the select button, and that's going to bring up the list of programs on the robot. Like I mentioned before, we can filter for those by selecting type and then coming down here and selecting TP programs, and this will bring up everything that is just a teach pendant program or motion program on the robot. So now I'm going to go here to create, and let's make our keyboard, and I'm going to call this demo test. And you'll notice that that is all in lowercase, but as soon as I exit out of that, it defaults to a uppercase lettering. Now if I want to look at the details of that program, of the structure of that program, I can come here to details, and this is where I can go ahead and select a different subtype if I wanted to pick a macro by just selecting choice. I can also come down and make a comment in the comment section, and any character in that section would work. I can use spaces, special characters, so it's a good way to add a short description of what is the program, what it does. I can also come down and mask different motion groups by either making a star or a 1 if the motion group is active. That can be enabled, which we definitely would want. And then I can toggle write protect and ignore pause, as well as adjust my stack size or memory for the program. 500 is typically sufficient for most TP programs. Okay, I'm going to go ahead and hit end. And so now it's created this program, and as you can see, there's nothing on there. It doesn't have any motions or any other logical statements that have yet been programmed. So if I want to move my robot to a location, let me change this to jog in user frame. And so I'm going to, let's just double check which user frame and tool frame that has. Okay, so 1 and 1, which is what we want. So with my shift enabled, I'm going to go ahead and move that robot to a new location. Let's just go somewhere over here in the middle of the board. Okay, and now I'm going to hit shift and point. So make sure my shift is selected and then hit point. And it's going to create a motion instruction. And then I can go ahead and continue to move my robot to some other location. Let's just have it go down in X. So we'll go there. We'll do a shift point again. And then we're going to go back up. We'll go up. This time we'll go up even higher. And create another point. And then let's go back. And create another point. Okay, so I've got these 4 points, and essentially the robot's just moving up and down the board. Right? So If I wanted to step through those, I would want to select step, and then I can hit shift, and now I'm going to do forward, and it's going to advance through each of those line items as I press forward. So the first one is it goes to point 1 that was taught, then my second point that was taught, my third point that was taught, and then back down to my fourth point. If I'm pretty happy with that, now I can go ahead and unselect or turn off step mode, and now hitting shift and forward, and it's just going to advance through each of those lines of instruction without pausing in between. Now if I'm in step mode, say I'm in step mode and I want to go to got to my first point, and then I go to my second point, and say for whatever reason I want to go back to my first point because I didn't quite like it, I can hit backward, and then it'll go back to that previous motion instruction. And so if I had stepped forward to say point 3, and now I move backward, it's just going to go back to point 2. If I hit backward again, it'll go back to point 1. So if I'm in continuous mode and I hit shift forward, and then let's say I hold it, and then I'm going to go backward, it's going to go back to that original instruction again, and then I can go back, I can step backwards one step at a time. Even though it's in continuous mode, it'll step back instead of running backwards continuously, or in a continuous fashion. All right, so now let's say I want to make an adjustment to these points. So let's make a couple of modifications. Let's say I want to make my position 4, I want to make it the same as position 1. So I can cursor over, highlight the 4 of position 4, and if I change that to position 1, it's actually going to change that now to be the same position as position 1. So now if I shift forward through that, I went 2, 3, and now 4, instead of coming all the way back, it went to where position 1 is. And you can see with the little @ sign, it's at each of those points. Now if I wanted to touch up a point, let's touch up point 2 to be in a slightly different location. Let's say we want to make that off to the, let's move in Y. We're going to move positive Y over a little bit. Now with my shift on, I can hit touch up, and it'll touch up that point again. And now notice it put the @ symbol, so we know that we're at that point. And so now when I go back to the top of my program and I hit shift, I'm going to just step through. Now it's giving me this caution that says I'm at a different point in my program than where it left off before. So when I had last stopped the motion, it was at line 2, and now I'm trying to execute it at line 1. So it just gives me an alert or a caution to say I'm starting at a different point in the program than when I left off. So I can just go ahead and hit enter. And now if I hit shift and step to point 1, now point 2, and point 3, and then point 4. And RoboGuide does a nice job of illustrating where we are moving to. So it shows with this blue path how we're moving from one point to another. Okay. Now taking step mode off, if I want to run this in auto mode, what I would do is turn my teach pendant off, and you'll see this little play button up here. This is the same thing as cycle start. So by selecting this, it'll cycle start just like it normally would in a program by activating the cycle start on this standard operator panel of the controller or through the user panel that might be tied to a PLC or some other function. But if I hit play, now it'll move forward through that.